Very well. So, welcome to everybody to the third edition of our multi-source Splashdown series. It is a pleasure to have you all to join us today. We will have another exciting exploration of cutting-edge topics of water management and the use of NBS. In this edition, we are going to talk about integrated wetlands, all-in-one system for raw wastewater, reuse and sludge management. Throughout this session, we will have the privilege of hearing two from our distinguished partners, speakers, Pascal Molle and Fabio Masi, who will share their experience and insights of the historical development, design, adaptation, and performance assessment of the treatment wetlands for water waste or raw wastewater. Having as a reference the work that we've been developing in multi-source project, of course. We will also explore relevant case studies from around the world, highlighting opportunities and challenges associated with adoption of this technology, also considering circular economy approaches. A little bit of introduction of our speakers. Pascal Molle is a research lead director from INRAE. He works in the sanitation of sewers. He uses vegetated techniques which allowed him to implement approaches that imitate natural behavior, especially within small and mid-sized communities. Fabio Masi is part of IRIDRA since 1998. He's a vice president of Global Wetland Technology since 2012. He is part of the task group Nature-Based Solutions for Water Sanitations, and he is a project co-author for over 550 projects designed worldwide. He's been consulting also in Europe, Asia, Africa, and South America. So please, I invite you all to encourage you actively ask questions. We will have a small, like 20 minutes at the end of the presentations. Please share your perspectives, share your questions. Remember that this Splashdown series serves as a platform for all collaborative learning and the knowledge exchange, and your contributions are invaluable in shaping the conversation. So we will start with Pascal. So please, the floor is yours. You have 20 minutes for your presentation. And thanks again to you and Fabio for joining us today. There you go.
Thank you, Laura. So I will share my presentation. You see it? Yeah, okay. And yes. Now, is it the good screen that you see?
No.
No.
Still not in presentation mode. Not even.
And here?
No.
No, it doesn't change. Okay, I will do like this. Should be good. But no.
No.
I'm not sharing anything, right?
No.
Okay, I do it again.
Yes.
Should be good.
Mm-hmm.
Perfect. So good morning, everybody. So I will present the evolution of the French system. The French system is the system that historically treat raw wastewater directly. It means that we treat the wastewater and the sludge as well. And I will show a little bit the evolution, and at the end, what we are digging in the framework of multi-source, the evolution to face new challenges. One of them being to be able to have a decentralized approach in urban areas and for reuse purpose. It will be a quick presentation, so obviously not enough time to go in deep in the detail of the design and performances, but just to give you a main idea. So historically, the French system, classical design is 2 stages of unsaturated vertical flow system. As you can see in this figure at the inlet, there is only a raw screening to be sure that all the pumping or gravity dosing can work properly. And on the first stage, we have 3 filters in parallel in temperate climate and 2 in tropical climate only. The idea here is to have a system that can retain the solids on the top of the filter to implement an organic deposit layer that will mineralize over years. And as well to start the process in terms of treatment of the dissolved pollution for COD, BOD, and a first nitrification step. And according to the outlet requirements, we can implement a second stage of vertical flow system, unsaturated as well, that aim at improving a little bit more the treatment, aerobic treatment, so to reach a full nitrification. And so basically there is the sludge treatment will be on the first stage, and the withdrawal of this organic deposit will take place after 10-15 years in temperate climates. It means that there is nothing to do during 10 or 15 years. And once we are withdrawing the organic deposit, it's well stabilized and mineralized, so we can use it for land application directly. So this system is designed according to load on the filter in operation, because there is 3 filters to manage this organic deposit, to have filling period and rest period, to be able to stabilize the deposit. Only 1 filter is in operation at the same time. And so we are looking at the load, hydraulic load, COD, BOD, TSS, TKN loads that you can see here. For the load, organic load, it's in gram per square meter and per day on the filter in operation. That's how we can design the surface we need to implement. And we have as well well-established removal performances for each stages. And so you can see that for COD, it will be 80% at the first stage, 90% for BOD, and 90% for TSS. So the removal performance is quite high. It's not the same for TKN, because for TKN, the more we are loading the system, the less we are treating TKN. So there is a relation that has been established that allows to define what will be the performances we will get at the outlet. For the hydraulic load, we have to take to have in mind that we can have higher hydraulic load when there is clear water intrusion in the sewer. So it's the water table from the ground that can enter into the sewer that can bring high and very often hydraulic loads. And so we know that in that case, we can double the load without any problem on the system. So it's to show a little bit the robustness of the system. So that's for the clear water intrusion. But if we are talking for storm water that can arrive in the sewer during rain events, here we have other rules. So we can design by security, increasing a little bit the surface of each filter. But we can as well use simple design rules that we developed in the framework of different research projects to be able to accept higher hydraulic load. And here you have an example here on the daily loads that we put on a full-scale system, 2000 people equivalent system. And you can see that if the nominal load is 37 in dry weather condition is 37 centimeters per day on the filter in operation, that sometimes here we can reach until more than 5 meters on the filter. So we can, if we design it properly, we can accept a very huge amount of storm water, because it does not happen every day. And so it's really important to show that we can face very large events of hydraulic load. Here, it's just to show that it's the removal performances that we can reach with the classical system. So it's really good aerobic degradation, below 15 for milligram per liter for BOD, below 90 for COD, 15 for TSS, and below 15 for TKN. It's what we can ensure, because on average, we are well below this. But if you look at the different inlet concentration we can see on our full-scale system, for the inlet concentration in black, and in gray the outlet of the first stage, and in yellow at the second stage, we can see that main of the treatment for COD, BOD, and TSS are done on the first stage. It is not the case for nitrification. It's more equilibrated between both stages. But the question were, at that time, is it possible to increase the performances of the first stage to avoid to have a second stage after? So to decrease the cost, to decrease the footprint, for example. And for that, there is different solution. We can use only one stage system and make recirculation. And for that, if we do this, we need to increase a little bit the surface of the system. We usually fit the system to have a 100% of recirculation. And then we can ensure those outlet concentrations. But recirculation means electricity somewhere. So the second question was, is it possible to work with one stage system without electricity and increasing the performances? And that's where another system arrived a little bit more than a decade ago. It's a vertical flow system, unsaturated on the first part, classically to French system, and below there is an increase of the drainage layer to implement a saturated vertical flow system at the bottom. The objective here is to be able to make denitrification. And who says denitrification says carbon consumption as well. And here you have an example of the performances we can have as denitrification in this saturated layer. And obviously, these performances will increase with the hydraulic time retention in this saturation layer, and as well will increase with the ratio of COD and nitrates that arrive at the saturation layer. So we have some main rules to define the denitrification efficiency in temperate climates, and the other points on the top are for tropical climate to show that with a high temperature, denitrification process is very fast. And for that, we can ensure high removal performances for BOD, COD, and TSS with only one stage. For nitrification, it will depend on the layer we will put for the unsaturated filter and the layer of the saturated layer as well, the depth of the saturated layer. So basically, we can reach level of 60% of nitrification if there is no recirculation. If we do recirculation, we can increase until 90%, but in that case, denitrification will not be good enough, and so we will be low in terms of denitrification with recirculation. But if there is no recirculation and that we can increase the retention time in the saturated layer, we can reach until maximum 70% for total nitrogen, which is quite interesting and can be suitable for certain context. And the question after is, if we want to implement system in urban areas for reuse purpose, we need to go further in terms of treatments. And if we look at different constraints that we have on the system in terms of treatment objective, from the very simple carbon to more complicated pathogen, for example, it's an example. And we look at some design rules here. I put only the compactness and the surface, but there is others. And if we look about external condition, can be temperate or extreme, for example. There is a zone here when we want to implement this in urban areas where we needed to dig a little bit more. It means that the zone is going to a high level of treatment, be really compact, and to face extreme condition. Because, for example, the more you are treating a small area, a building, or for example, you will have a lot of load variation, concentration variation. So we need to face this, and for that, there is a system that has been developed by a company, a private company, EcoBird, that implements this possibility to accept raw wastewater on the top, but on the bottom there is aeration, forced aeration, to increase the performances. The system is basically composed of two filters in parallel, just separated in the middle. The first layer of the system is unsaturated, but very, very teeny. It's only 20 centimeters. And below there is a 1 meter deep system saturated, in which we are blowing air to bring oxygen according to the needs. So basically, when we are feeding a system here on the left, the water will have a mix of vertical and horizontal flow. And then the outlet will be on the other side. That means we'll go through the other filter, but below the unsaturated layer, to get at the outlet here. So here we'll get a horizontal flow. And so we have a primary filter where we are feeding the system, and a secondary filter when there is no feeding during 3 days and a half. And when we do rotation, it's the opposite. That means we are feeding here, and we close the valve here, and the outlet will be on the other side. With this system, so there is different full-scale systems that has been done for small villages, and that we monitor, and we are still monitoring all of them. There is something like 25 systems like this in France actually, and you can see that it's really good for COD, BOD, TSS, and even nitrification. It's in one stage a full treatment, and for nitrogen form, it will be different according to how we are managing the aeration strategy. If you look at the evolution of oxygen concentration in the saturated zone, you can see that we can put sometimes aeration on to put oxygen, and then stop aeration to decrease and implement some aerobic phase and anoxic phase. And thanks to that, we can improve TN removal in the system. The question is where and when to put on oxygenation in the filter, because we can do it differently in the primary and in the secondary filter. The other thing is that we need as well to adapt the design of the aeration system itself. And for that, we needed to understand the role of aeration. And so there is here an example of how air is distributed inside a column according to the airflow, to the type of material we put in, and to the number, the density of diffuser we have. Basically, we can see that it is possible to have an uneven distribution where there is no color in the column. It means that we do not see where the air is passing because it's too teeny in the middle of the column. And so the bigger is the material, the more we will have a heterogeneity at low flow, and we will need to increase the airflow or increase the diffuser density to have an homogeneous distribution of air inside the system. And then we can look at as well, according to the number of diffuser, to the particle size of the media, how much oxygen we would transfer to the system, which is really important in design, because we need to know exactly what we can transfer for the consumption, for degradation of pollutant and the consumption from bacteria. And we can see that if we increase the airflow, we are increasing transfer, but we reach a plateau until a certain moment that show that there is no need to go to high airflow, because in that case, we will consume too much energy for nothing. So we have rules for that. And then the question is where to put aeration in the system and how much. And what we observe that it's really important to have a good aeration strategy in the primary filter, because it's as well a way to have a good mixing and to avoid any hydraulic short circuiting inside the system. So it's really improve the performances. And after, what we can see, so there is no difficulties for the carbon degradation, I would say, and solid degradation or entrapment. We can reach full nitrification easily, but for TN removal, there is different strategy for that. We can do it by time, by flow, according to the inlet flow, or with a probe that we can put inside and control aeration according to the oxygen content. And so by time, we can reach 70% of TN removal. By flow, we can be a little bit more precise and reach 80% of removal. And by oxygen content, it's what we are digging actually a little bit more in the framework of multi-source project. There is already a first paper that discusses all this strategy, but just showing that we can go quite far in the TN removal as well in only one stage system. Not presented here, but which is important for reuse purposes as well, that we are monitoring the system as well for pathogen removal and for micropollutants removal. No time in this presentation to speak about that. Well, thank you for your attention, and if you have any question, I'm here.
Thank you very much, Pascal. This indeed is super inspiring, also for keep on digging and consulting, especially this paper. I'm very curious about it. I'm definitely going to have a look, like also to keep on learning these aeration strategies and how these wetlands also are working for wastewater treatment. It's very, very inspiring. The questions, please. We are going to have the presentation of Fabio. So afterwards, then we open the floor for the discussion. But for the moment, Fabio, the floor is yours.
Fabio, your mic, Fabio.
Yeah, the mic is muted.
Sorry. So I start again.
It's fine. There you go.
But so the screen is good.
If you were sharing the screen, so maybe you can.
I'm not anymore. Oh, good.
Yeah, you can try again.
Yes. Good. Now it's fine. Is it?
Now it's perfect.
Good. So many thanks, Laura, for the nice introduction before, and thanks to Pascal for the perfect explanation of the processes which are behind this kind of technology. And what I'm going to show to you is just how we practitioners have applied the theory in the real world. So I will just show some case studies of the different kind of implementations for this technology. So I'm just starting with some pictures of the oldest systems, which are the ones developed in France. In France now, they have several thousand of these systems. If I remember well, it's about 5,000 at the moment, the ones which are full-scale realized in operation. They are all even quite well monitored, and there is an available, at least for somebody. I mean, not everybody has access to it, but there is a national database where all the data is well organized, and so it's possible to understand the performance statistics even for quite long performance period. operational period. In this picture, I've also put a picture of this self-priming siphon. That's the one more adopted for giving a lot of water in the unit of time and not using energy to the beds, the two following stages of the beds. And here you see, for instance, realization phase of the systems where you can immediately understand that the first stage is where you have only the 4 exit points and where you will have to load every sector of the bed alternatively. So one day you feed one, the day after you feed the one behind, and so on, besides, sorry. And then there is the second stage where you see all the distribution pipes on top of the surface, because that's evidently a vertical flow second stage. And here you can see in detail how feeding system, those are normally steel pipes, are mounted over the first stage of the full system. So those are all installed in France, and the normal range has been for several years below 2000 PE, according to the Urban Wastewater Directive of the European Community, which is nowadays anyway changing, and now the threshold for having a mandatory biological treatment, so the secondary treatment, is going to shift to 1000 P, and that's opening the market for this kind of French systems for about 350,000 small settlements, which are beside 1,000 and 2,000, which are present in Europe and still untreated. And that's only the European market we are talking about. And it's already a quite good number in terms of market exploitation chances in the future. So here you see some details of the siphon. That's how the feeding system is tested at the beginning. When we are putting them on site, we are just measuring that the height of the jets of water from every small hole has having the same elevation, in order to have a quite good and even feeding of the system in all the square meters we are designing. Otherwise, there are dead areas of the bed which are not used, and so bad investment. And now I start with the cases done in Italy by us directly. That's, for instance, a village of about 1,000 P on the Apennines, so it's top of the mountain. So it's 1,400 meters of elevation, quite cold in winter. It's all covered by snow. And here you can see that the investment cost is 400,000. We have an OPEX quite low, as we have demonstrated, even publishing a paper about that we are reaching as OPEX about €6 per person equivalent per year, which is quite a very low number if you compare, for instance, with an activated sludge. In this paper, we compared with an SBR. And for the SBR, the O&M is around 60, let's say. It's ranging from 45 and 75. So let's assume 60. So it's like 10 times higher in terms of OPEX in comparison to a nature-based solution. The performances we have obtained here have been monitored by the water utility, the local water utility, and as you see here, we are for all the parameters over the 95% of removal. A very nice installation is in the south of France. Negrepellis is the name of the village. That's a quite huge installation, and here finally the limit of 2,000 was superated somehow, and here they are treating about 4,000 population equivalent, and there are several of these 4,000 P systems nowadays in France, this system is quite particular because it's treating both the mixed sewer wastewater with this installation of a double-stage French reed bed. But there is also, beside this installation, another smaller one where they are collecting all the sludge harvested by trucks, the primary sludge from the septic tanks, which is then treated locally by sludge drying reed bed unit. That's quite a beautiful system, quite complex. And what I wanted to show is that when we shift the sites and we go from the few hundred to thousand of population equivalent, obviously the feeding system is getting more complex. And then we are using pumps and PLCs in order to manage all the feeding iteration. Some pictures to show how these kind of systems can play quite good in terms of aesthetical insertion. And so it's quite nice to insert in the designing teams, some landscaping architects, because you can really make this kind of installation as fruition areas where also people can go around and enjoy the nature. So those are still pictures to show you how these systems are looking after a few years of operation. And here you can see, for instance, the sludge, the layer, which is just growing on in the time in the first bed, and then the sludge after quite long period of composting that can go up to 10 years. Is just dig it out and then use it as soil conditioner. Following this nice experience they were doing in France, we, as IRIDRA, won a tender launched by the World Bank. And we convinced the World Bank that just replicating in parallel lines what in France was done for 4,000, for instance, if you make 5 parallel lines, each one for 4,000 P, you can go up to 20,000. If you make 6 of them, you go up to 30,000. And so the engineers of the World Bank were convinced to this kind of approach of replicating something known, something working well somewhere else. And then we designed these parallel lines, just replicating the French installations in Moldova for the city of Orey. And that's at the moment the biggest French systems existing in the planet, because it's about 3 hectares, 3.5 hectares in total. Here, obviously, the feeding is quite a complex thing, and we are using a lot of pumping stations and PLCs for obtaining all the right feeding. And the performance are quite good, even in so drastic climatic conditions like the minus 35 degrees in winter, where we are still obtaining good removals also for the nitrification, which is obviously decreasing in cold temperature. But we played everything in order to keep the temperature of the water high enough, at least for not being frozen, let's say. And so just discovering that we were able to work properly also in cold conditions, then we decided to go up to the mountains. And those are some applications we have still developed with our French colleagues of Symbio and Ecobird. In this case is Symbio. And we worked in a Interreg project where the Italians were installing on the Italian side. And so that's the Maritime Alps in the Cuneo province in Italy. It's a small system, but you still see how the performances are fine. And here at the double stage is a French first stage, and then a horizontal flow for the second stage for completing the nitrification. And a similar installation has been done on the French Alps on the other side of the mountains, let's say. Then another kind of application was related to the high strand wastewater fluxes. So when you have a lot of organics, then French reed bed as first stage can perfectly work for keeping there most of the organics. So we still have, even with very high strand, 75–80% of removal of the organics in the first stage. And that's perfect when you have exactly this kind of wastewater where the COD can range to up to some 1,000 milligram per liter, especially in some periods, like whenever they are making washing of the containers where the wine is contained during the periods in which they are processing the grapes themselves and so on. So that's quite a whole system. The first one we applied for a winery. At the beginning, it was simply a horizontal free water system for 50 cubic meter. It clogged after the production doubled the capacity, and so they doubled also the wastewater. So we made an upgrade of the system, adding the first stage of the French reed beds. And then we just doubled the horizontal flows and kept the free water as it is. So that's a multi-stage system. And the concept of using the French systems in multi-stage constructed wetlands is very valid, because we can just assign the role, for instance, to the first stage to make this good filtration of the organics and the suspended solids. And those are the ones you see here in the picture, are exactly the French reed beds installed there. And we have a very long monitoring. We have a COD sensor, which is giving data every 30 seconds in the outlet. So we are really able to monitor the system along the time. And we have quite a long, like more than 10 years of monitoring. And as you can see from this graph, the performances are constantly good for all the periods, even when we get peaks of up to 10,000 milligram per liter of COD in the inlet. And what we have observed, for instance, is that the growing rate of the sludge, so how the sludge is accumulating in the first bed, is about 1 centimeter per year. So if you make I don't know, 20, 30 centimeter of free banks, that's giving you the chance to accumulate the sludge for a period of even 20 years before to have to dig it out and use it as a composted sludge in agriculture. Following this first experience, we had a lot of other contracts still in the Italian market of wineries. And so we developed several of them, where in all of them, we are putting French reed bed as first stage, and then horizontal and free water for refining the treatment afterward. The free water is not so essential. We do that only when we are in flat areas. But for instance, this one is instead a hilly installation, so we had to make terraces. And in this case, the first stage, which is the same one, here is followed by a second horizontal flow in the second terrace, and there is no free water because there was not room for that. If we compare in terms of saving that we can have by this kind of system comparing to SBR, the CO2 equivalent emitted is much less than. So you see the consumptions here, SBR. Plus wetland, that's pure activated sludge, and that's what we obtain instead in the 7,800 is exactly what you obtain in our constructed wetland. And so we have a reduction of about 43 tons per year of CO2 emission and a 90% saving of energy, which is quite good. Still going up with the scale, that's what we are monitoring exactly in the MULTISOURCE project, trying to optimize the aeration rate. So when and where and in which occasions to turn on the aeration. And that's a treatment which is a treatment system which is treating the water coming out from the very last bypass before a centralized wastewater treatment plant located in northern Italy. The system is, the WWTP is quite good, is 1,200, 120,000 population equivalent, and the treatment is a French reed bed which has the aeration on the bottom, so quite similar to the rhizosphere that Pascal was showing in the very last slides. And that's followed by a free water system just for renaturing the water before the insertion in the Lambro River, which is quite a polluted river in the north of Italy. And so here the aeration is diffused in all the 4 cells that we have, and that's a way. So we have been forced, for instance, to add here the aeration because the area was not big enough for having, in hydraulic terms, passive the chances to implement a passive treatment instead of an enhanced one, which is exactly what we obtain adding the aeration on the bottom. And I just want to show you what are the costs for a so huge system. So in the order of 100,000 PE, it's about 37,000 euro per year of total cost, and you can see above how the cost, this amount has been obtained. Similar installations are done also in France, where they have several systems which are now treating combined sewer overflows. And the very last, which is anyway in my mind one of the best applications we can think about for the next future for spreading this technology all around in the world, is just to try to replicate the experiment we have done in the HydroUSA project in this Hydro 1 demo site in Lesbos. That's treating 100 cubic meter per day. It's a UASB, so anaerobic treatment followed by a saturated and then unsaturated vertical flow constructed wetland double stage. But let's say that the first unsaturated stage, but also the anaerobic reactor, can be fully substituted by the first stage French reed bed with the same results. This system has been very deeply monitored for more than 2 years. We have demonstrated that we can reuse the effluent after UV disinfection for making fertigation. So here our aim is not to make denitrification and to use instead the first stage of the French reed beds as a good nitrifier. And so we are producing a lot of nitrates, which are good as fertilizers. And we go in fertigation, and we have demonstrated that the agronomic yields are quite good, are very good. I would say completely comparable with synthetic fertilizer fertigation schemes. And it's even safe. So our Spanish colleague in Girona is making the analysis of the micropollutants, and there are no big risks for the moment that have been put in evidence. So we got the ATV, which is the environmental technology verification, and we are simply replicating the installation of Hydro 1 in our island in Italy, Gorgona Island, where we have installed our first passive horizontal flow wetland like 25 years ago. And now we are making an upgrading of it, just substituting the first 2 horizontal beds with 2 French systems, and we will then reuse all the effluent for fertigation. And as a very last practice, a kind of application, we can even treat kind of industrial wastewater. For instance, there are in France some applications for motorway facilities. And obviously, as all constructed wetlands, we can play with quite fluctuating fluxes when we have alternation of periods where you have high presence, for instance, of humans producing wastewater, and that's exactly the condition that is very common for the touristic sites, where this kind of MBS can obviously play a good role, assuring good performances along the time. And we all have concluded. Many thanks. I'm open to questions.
Thank you very much, Fabio. This is very, very insightful, especially looking at all these applications. it, I think, in my perspective, sorry, gives me a very clear idea how all these systems that Pascal was explaining, like very in a theory and how does it work, but in application, I think is very, very inspiring how we as researchers, applicants, and all these type of projects that we are gonna reach into these nature-based solutions for treating water and also for urban planning and so on. I think it gives a lot of good ideas and also inspiring for other research as well. So opening the time for discussion. So please, if there is some burning questions, I invite you all. Don't be shy. Open your mic. If you don't want to turn on your camera, it's fine. But we will appreciate to see your faces. It's nice to have a conversation with a face. So maybe one question from my side to break the ice would be, after looking all these applications, and also Pascal was talking about some challenges, but looking ahead, what is the main challenge that you foresee in the future regarding the integration of these nature-based solutions into the treatment of water wetland design in an urban place? Like Pascal, you were talking about some specific things about the system in an area, but what would be like in practice that you think this in an urban area, what would be like the most challenging aspect that you will consider?
For me, the first issue we need to face is that if we want to apply this in urban areas, that means in a decentralized approach, it changes a lot the way all stakeholders and the people funding urban water management are doing actually. And so it's changing their work a lot, changing their point of view, and it's something that is done now more and more for rainwater and stormwater, but for domestic wastewater, it's we need we need time and convince them that it can be more interesting and more resilient for cities. And basically, with all the discussion I had with many municipalities, they are not too afraid about the technology itself, but it's just that just having several treatment plants in the city makes them thinking that it would be maybe complicated to manage, but they don't looking at the management time and cost they will save on the sewer management. And so we need to have this large view and showing not only the treatment system itself, but all the sanitation system. And that's where the decentralized approach and NBS are really, really interesting. And concerning the technology itself, with the fact that we can treat the sludge on the top, obviously there is a question, but which is not really complicated to manage, is that the possible contact with citizens with the surface of the system. So that means that this system will have to be closed from citizen at least the first stage. After we can see, but to minimize the possible contact and so the sanitary risk with citizens. But it's not really complicated I think, to manage this.
Good. Thanks a lot, Fabio. You wanted also to comment something.
Well, yeah. For instance, in our direct experience, we are starting now. So the system I've shown in Castelluccio has been, for the moment, the only one we have made for a municipality in Italy. And we are starting now interacting with big water utilities, let's say some companies which are still owned by Veolia at the end. So almost all Italy now is under the French dominion in the water sector. And so they finally, maybe for the French influence behind, but they are now starting showing some interest. So we are designing a few systems for the central part of Italy. And what these water utilities guys and ladies are more scared about are exactly the consumption of land, which is something that is obviously still about 10 times higher in comparison to compact solutions, even when you go to the centralized alternatives. Let's say we are still consuming more area, more footprint for installing your system in comparison to an activated sludge or an SPR or an MBR. And then that's the first concern. So how to acquire that area? If you need to buy it, that's an additive cost to the capex of the system, let's say. And the other one is exactly what Pascal was talking about: to have the raw wastewater treated directly in an exposed way on the first stage. And so their concern is, will these develop mosquito communities? Will these develop bad odors for who is living around, and so on? And so we, for instance, we had to bring them visiting existing French systems in France in order to show them, yeah, that's an operating system since 15 years or 20 years. Look how it's performing. You have these impacts, but you have these impacts only for very few minutes per day at the end, because, for instance, you are pulsing the water for feeding only a few times per day and only few minutes each time. So when you really see the water exposed, is really a rare moment. It's not so easy to see the feeding time. Just if you stay there a lot of time, you will see this event taking place. And so you can have this kind of impacts. And for instance, in the design guidelines in France, they are advising minimum distance from the closest house. And we are applying almost the same kind of criteria also in Italy. We also have regulations which are obliging us to have a minimum distance from the closest house and inhabitants. So yeah, those are the main concerns. But what is appealing a lot instead of the stakeholders is the very low OPEX, much lower than the other installations they are used to do. And the easiness of manutention, let's say, so the maintenance is much easier in comparison to technical systems, and they start appreciating it. I mean, they understand the potentiality of this for saving time of their personnel and obviously personal cost.
I can jump on the question about the constraint, the possible constraint for citizens close to the system, and in relation to the comment on the chat about smells.
Thank you.
And it's well, it's when we are shooting domestic wastewater, it's still a wastewater treatment plant, and there is some smells that can come from the sewer. That means in the siphon or in the pumping station that produce some that will produce the dosing on the system. We will accumulate a certain level of water until to reach a good volume for distribution. And so in this area, according to the length of the sewer before, we will have wastewater that will be stored during some a few hours, 1 hour, 2 hours, 3 hours. And so it's possible that in summer, when it's really hot in this pumping station or siphon dosing system, that the water come to anoxic or anaerobic condition. And so where we are dosing the pulse, there is a stripping of the gases that can produce some smell sometime, but the smell is only close to the system. If you are 15 meters away, you are not smelling anything.
Yep.
And so it is not the question of the technique itself, the treatment technique itself. It's what is coming from the sewer, because it's raw wastewater, and the more it's organic, the more it's hot, the more you can have this issue. But as Fabio said, it's only 10 minutes in a day, because the dosing it's 10 times 1 minute, for example.
Exactly.
So it's very short, but it can happen. But the system itself is aerobic system, so there is no methane or H2S production.
Yeah. Instead, still, I was also looking at the chat, and Bent is asking for a comment about the combined sewer overflows. That's what we are quite experienced at the moment in north of Italy, in Lombardia. We have installed a lot of them. And what I have to say is that all the citizens that we have even interviewed, spreading questionnaires in the municipalities and so on, are very, very happy about the installation of this sort of water green parks, because we made them accessible with, I don't know, bike tracks, tables where to sit and so on. Even because they are getting flooded only occasionally when we have rain events, and in all the dry periods they are just normally abandoned areas which were not in a so nice shape, let's say, before our intervention, nearby the stream where the combined sewer outflow was discharging. And when these combined sewer overflows are discharging improperly without any treatment, what you get on the river is a big impact. I mean, you see in the inlet point in the river a lot of plastics around, foam. For instance, in north of Lombardia, we have a lot of rivers where normally everywhere you have a little fall of the water, you develop like 10, 20 centimeters of foam, white foam, all above the surface of the river. And that's exactly what the combined sewer overflows are producing. So citizens are quite happy to see that the river quality immediately after the installation that we are doing is improving, even not in a so perfect way, just because not all the combined sewer overflows along that river have been remediated at the moment, but we give examples how to behave for a better future, let's say.
That's great. That's great. Being aware of the time, we have one last question in the chat. So should I read it out loud, Alba, or we'd like to open your mic and maybe you can go ahead? Okay, maybe I can just read it out loud. The question from Alba is, have you observed any shift at the European level towards the adoption of a unified policy aimed at the promoting, financing, or facilitating the implementation of treatment wetlands? If not, how can we achieve it?
Difficult
and maybe
question.
just 1 or 2 minutes for the answer.
Just a comment that means that the European level there is some objectives to promote NBS in general in cities, but there is no specific links with urban water management. And if you are looking at the new directive that is under discussion for wastewater treatment, it's still, well, they cannot specifically address the technology, so they do not address NBS specifically. But what we can see is that they are staying in the centralized approach. And I think that's something we need to face and to try to convince politicians and regulators looking at the whole sanitation system that the decentralized approach is possible and can be even smarter in some times.
Yeah, I agree, definitely. And that was actually one point that we discussed last Splashdown with Paula and Maria, also partners from MULTISOURCE. Governance is one topic that we are aiming as well within our MULTISOURCE project, and this is key for all the research and application that we want to do with nature-based solutions, definitely. Thank you very much, everybody. we are following this invitation in the following weeks with the 4th Splashdown. Thanks a lot for the questions. This is very, very exciting to engage with more and more of you. And yeah, we will try to fix also the times, trying to involve also the other time zones that are kind of like difficult to put all together at once. But yeah, thanks a lot to Pascal and Fabio and everyone in the room. Yeah, have a nice day. Thank you very much.
Bye. Have a nice day too.
Bye-bye. Thank you all.